All right, so now we're getting into subatomic particles. We already saw who came up with stuff. Now they figured out, ooh, there's subatomic particles beyond an atom. So what did they find? They found that there's a proton, neutron, and electron. They also found the locations. Protons are in the nucleus along with the neutrons, and electrons orbit. They came up with the charges. Protons positive, neutrons neutral or zero, and then you have electrons negative. Now when we get to mass, we look at something called an AMU. Well, why are we doing AMU instead of kilograms? Well, it is much more convenient to use the atomic mass unit than to use grams, because as you can see, it is very, very tiny, like really, really, really tiny. So instead of writing all these out, we can go by the AMUs and have a 1 or not even worry about electrons. So an AMU equals about the mass of 1 proton or 1 neutron. In 1 gram, so when I was talking AMUs is so much better, 1 gram of an atom, 1 gram of an AMU, 1 gram of proton is 600 sextillion. And a pound is 300 septillion AMU. That's why we use AMU instead of grams. So proton and neutrons account for almost all of the atom's mass. So if there's a proton, there's 1 there. If it's a neutron, there's 1 there. They all are 1. But here's the thing. We don't really look at the electrons because the electrons weigh so little that instead of looking at electrons for weight, we look at electrons for how big it is. Because the electrons build those shells, make it as big as it is. That makes the volume, like how big it is. So now we have atomic symbols. Page 9 of your reference symbol right here. And we are looking right about here. Right there, okay? So looking at this, we have the first thing, or A. That one equals the total number of protons and neutrons together. Like everything all together. And then that is the number of the nucleons, like what's in the nucleus. Then you have Z, this number down here, at the bottom part of the left-hand side. That one equals the number of protons. And it identifies the element. Very huge thing. This is what identifies the elements. It also can help figure out the nuclear charge. How is that? Well, in the nucleus, we can figure out what's in there. How do we figure it out? Well, we take that mass number, that's everything in the middle, we subtract the atomic number out of it, that number right there, the number of protons, and we get the number of neutrons to help figure out the nuclear charge. Right? And this works on isotopes because we don't always have the same, like just the same number of the certain elements. The elements can fluctuate a little bit depending on how many neutrals are in there. Remember, the protons tell you what element you're looking at, where the neutrons help make up the middle. So what is this talking about? Isotopes. Well, how do we figure out isotopes? This one right here, what we were just looking at, is carbon-14. I don't know if you remember hearing carbon-14. This is for radioactive dating. And then you have carbon-12, which is the normal carbon. If you were to look right here, right there, carbon-12 is the normal one that you see on the reference table. That is the neutral. Like it has no charge, it is neutral. Then you have these isotopes. They are not neutral. That gives you that charge. Looking at this, carbon-14, if you take that atomic mass and subtract the atomic number, you get the neutrons. You get 8 neutrons for this carbon-14. So that gives it an extra charge. Whereas the normal carbon 12 minus 6 gets 6 neutrons with 6 electrons. That is a neutral atom, a neutral element. Whereas the carbon 14 is not neutral. So we're going to do a couple exercises. Let's look at the copper 65 isotope. We're going to figure out the symbol, the atomic number, the mass number, the number of protons, neutrons, electrons, and nucleons, you know, the stuff in the middle, and then the nuclear charge. All right, so let's look at the first one. All right, so I'm going to do this with you right now. Let's look at the symbol for copper. Copper is Cu. If you don't know that copper is Cu, or if you don't know its symbol, you can simply go to Table S and look at the names and the symbols right there, all the way down, okay? So copper is Cu. And if you look on here, Cu is right in the middle, right there. So copper. And we have copper 65. And I'm going to put on the bottom. So if you look on there, you will find, double checking. So we're going to put 65 up here and 29 down there, right? The symbol is Cu. The atomic number is going to be, 29. The mass is going to be 65. Now we can figure out the protons, neutrons, and electrons. So here's the thing. With isotopes, the electrons are going to match the protons. So we already know that. This goes a little fast. So here's that. There's that. Atomic number is 29. Mass number is 65. Number of protons we know is going to be 29. Number of electrons is going to match 29. Now we're just going to take 65 minus 29. 15, 6, 5, 4, 3. It should be 36. And I just did quick, simple math. All right. Number of nucleons. How many is in the nucleus? That is going to be the same as the mass number. The nuclear charge is going to be the 29. It's going to be the protons. All right. So if an atom contains 9 protons and 10 neutrons, what you will do is you are going to put down on the bottom 9 right here. Right? And I'm going to look on my reference table, and I'm going to find the 9 is F. And we know there's 10 neutrons. 10 plus 9 is 19. That will go up there. So it's fluorine 19. 9 protons. 9 is the atomic number. 9 electrons. Let's find out, and we already know the neutrons. The nuclear number is going to be 9. All right? That is it. You're going to finish up the travelogue, and I hope you guys have a great day.